Today's video is about dilations and scale factors, so get your notes out and get them ready. The first thing is this part right here, just information about dilations. And when a figure is dilated, the size is changed by multiplying. We have to multiply every time. So we multiply the length of every side by a constant number. So the same number every time. And all angles do remain the same, which means it is similar. So you don't have to draw this, but if you have two triangles and one is dilated, and maybe this is by 2, you multiply that by 2, these two triangles would be similar. Maybe these are both right angles, maybe this are 45, and so are these two here. So those would be similar figures. So example 1, we're going to use a scale factor of 3. And I always like to circle the scale factor just so we can see it a little bit clearer. We're going to dilate ABC to A prime, B prime, C prime, and get the length of the new sides. So AB is originally 5, but times 3, that would give us 15. So that's AB. BC is 4, and 4 times 3 would give us 12. And then our last one, CA, is 3 times the scale factor of 3 is 9. So right here is our scale factor. Every single time we multiply by 3, and then we have our answers right here. AB prime would be 15, BC prime would be 12, and CA prime would be 9. So when something is dilated, it gets bigger. So from here to here, that means that it's being multiplied by a number larger than 1. So if we have these two, maybe this is 2 and this is 4, what's the scale factor? 2. When something is getting smaller, it is being multiplied by a number less than 1. So maybe we have this triangle to this triangle, maybe we have 9 and 3. Okay, so we have to be multiplying, not dividing by 3. Instead of dividing by 3, we would say times 1/3. If we were dividing by 4, times 1/4. Dividing by 5, times 1/5, and so on. Okay, so example 2, use the scale factor of 3/4 to dilate the pentagon. So is it going to be bigger or smaller? 3/4 is less than 1, so our new one is going to be smaller. So what we're going to do is we're going to do 20 times 3/4. Since you're going to put 20 over 1 to make it a fraction, so 20 times 3 is 60. 4 times 1 is 4. 60 divided by 4 gives us 15. So 20 would become 15. 12 times 3/4. Again, I'm going to put 12 over 1 just to make multiplication easier. 12 times 3, top times top. Bottom times bottom. 36 divided by 4 is 9. So this side would become 9 here, 9 here, and all of these would be 15 in the dilated shape. Now, that's how to find the new measurements. If we're going backwards, finding what is the scale factor, we have to know which one is the original and which one is the image, or the new one. So the original one and the image, the new one. You can set them up in this ratio. Image is the new one, over the old one, the original. So look at this, example 1. What scale factor is used to dilate WXYZ to W prime, X prime, Y prime, Z prime? So first we have to figure out which one is the original and which one is the image. Since the smaller one, this one here, does not have the prime marks, see how that says Y prime? it has to be the original one, this one here. And the one with the marks is the image. So what we're going to do is we're going to look at the sides. Here's the image, 20. And the same side on the other one, the original, is 10. Well, 20 divided by 10 is 2, so our scale factor is 2. Now here's a way to double check yourself. Is it getting bigger? Yes. Is my answer greater than 1? Yes. So then we know we've at least got on the right track. In example 2, which one is the image? A, B, C, or A prime, B prime, C prime? So what we're going to do is we're going to pick one side, any side, doesn't matter, because they're all in the same ratio. It doesn't matter what we pick. So maybe we say pick 15. That's the one from our original. So 5 would be the same side that matches up. So we put 5 there. So original, new, image, 5, the new one, over the original, 15, the old one, would reduce to 1/3. Okay, so you can pick any side. You can write that there. Because look, if you were to do 4 over 12, wouldn't 4 over 12 reduce to 1/3? And if you were to pick 3 over 9, wouldn't 3 over 9 reduce to 1/3? Yes. So all of them would be a scale factor of 1/3. That is all the notes. Flip to the back. You've got 3 practice that I want you to do. I'll kind of help you with number 1, and then you'll do 2 and 3 completely on your own. So what I want you to do is for K, L, and M, I want you to write the points. Now careful on this. Look at how this is going by 4s. So K is at -4, 4. L is at 4, 4. M is at 4, -4. And N is at -4, -4. So all I've done is taken these points and written down where were they at. Our scale factor is 2, which means we're going to multiply every point by 2. So what's 4 times 2? 8. 4 times 2, 8. And I'm just keeping the negatives. Okay, so -4 times 2 would be -8. Positive 4 times 2 would be +8. So this would continue like this. And then the last step is to just graph it. So K prime would be at -8, +8. So up here. L prime would be at 8, 8. M prime, 8, -8. And N prime, -8, -8. And then you just connect the dots to form your dilated shape. So it has increased by 2. Okay, these are your last 2. You need to do both of these on your own. And then this is going to go in your notebooks when you're done. Thanks for watching.